Okay, so section 10.1 is exponential functions. So that's what we just did with our M&M activity. We made an exponential function. So an exponential function can look like y equals b to the x. Oops. B is a constant greater than 0. It can't be equal to 1 either. You can't have 1 to the x. It would always just be 1. And the exponent x is the independent variable. We call b the base. So let's say we have f of x equals 2 to the x. So that's our exponential function. We're going to evaluate the following.
So f of x squared.
Oh, I'm talking on here. Hang on.
Minus g of x squared.
I was uploading this video earlier.
Dx.
That scared me. All right, so anyway. So let's start with f of x equals 2 to the x. So we'd have f of 3 is 2 to the third power. So f of 3 is equal to 8. Okay, the next one, f of 3 over 2. So f of 3 over 2 is 2 to the 3 over 2. You guys remember what it means to have a power of 3 over 2?
It'd be like square root of 2 cubed.
Yep, the bottom number is your root. The top number is your power. So it's 2 to the third power under a square root. So that's square root of 8, which is 2 root 2, which is like 2.83, so somewhere around there, 2.83. Okay, you could also put that in your calculator as 2 raised to the parentheses 3 over 2. All right, f of negative 3 over 2. Okay, that's 2 to the negative 3 over 2. So it looks really close to number 2. It's just a little bit off. So we just have that negative. So what does a negative power mean?
Reciprocal.
Yeah, 1 over. So I have 1 over 2 to the 3 over 2. So that means it's 1 over that 2 root 2, or square root of 8. So if you figure out what that is, it's 0.35. It's somewhere around there. Okay, and the last one is f of pi. So f of pi is 2 to the pi, which is 8.82. So somewhere in there. Okay, so we're going to go ahead and graph the exponential functions. So it says use the information from above to fill in the following t-table. So I have several of these marked already. Those are the ones we just found. Okay, what if I have 2 to the 0? Nope, not 2. Not 0. 1. Anything to the 0 power is a 1, remember? All right, 2 to the 1, that's the one that's 2. 2 squared is 4. 2 to the negative 1. Negative 1 means 1 over, so it'd be 1 over 2 to the positive 1, so 1/2, or 0.5. And 2 to the negative 2 would be 1 over 2 to the positive 2, so 1/4. Okay, so let's graph all those points. So the point 0, 1, these are kind of hard. We're pretty close to each other. 1, 2, 1.5, almost to 3, so 2.83. 2, 4, negative 1, 1/2, negative 1.5, 0.35, so it's getting even smaller. Negative 2, 1/4, so even smaller. And then pi shoots all the way up to 8.82. So like 3.14, comma 8.82. Okay, so those points are graphing out an exponential function. Looks like that. All right, so let's try the next one. Oops. All right, so it says use the information from the above t-table to fill in the t-table and graph g of x equals 1/2 to the x. Okay, so if I have 1/2 to the 0, okay, anything to the 0 is just 1, so that's 1. 1/2 to the 1 is 1/2. 1/2 squared, a lot of people in the last class said it was 1. 1/2 squared is 1/2 times 1/2. So it's 1/4, right? 1/2 to the -1. Yep, whenever you see a negative exponent, you take the reciprocal of the base. So it's 2 to the +1, which is just 2. So same thing here, 1/2 to the -2, I'd take the reciprocal of the base. So I'd have 2 to the +2, which is 4. So graph all of those. So I have 0, 1, 1, 1/2, 1/2, 0.35, 2, 1/4, so even smaller. Then I have -1, 2, -1.5, 2.83, -2, 4, and then pi is really, really tiny. It's 0.1. Okay, so this graph goes along here. So when I talk about exponential growth and exponential decay, which one of those was exponential growth, do you think? Yeah, the first one. The first one got bigger and bigger and bigger. So if you go back to it, see how it went up? So that's growth. Notice how it was y equals 2 to the x. So your base, 2, when it's bigger than 1, it's going to be growth. So it goes up. Okay, but on the second one, so when I had 1/2 to the x, that number that we had was between 0 and 1. So that's decay. In other words, it goes down. So as I go to the right, it gets smaller and smaller and smaller. All right, so exponential growth is going to look like that. Exponential decay looks like this. And notice both of them went through the point 0, 1. That's because both of them were in the form y equals b to the x. So if I plug in 0 for x, I get b to the 0. And b to the 0 is just 1. So both of them have the point 0, 1. So for the exponential growth, b is greater than 1. And this one's y equals b to the x, where b is between 0 and 1. So we write 0 is less than b, which is less than 1. It's saying it's between 0 and 1. Okay. All right, next up. So we talked about horizontal asymptotes. These exponential functions are going to have horizontal asymptotes because you can't do 2 raised to something and get 0 out, right? That's not going to work. So 2 raised to something is not going to give you 0. Same with like 1/2 raised to the x. That's never going to equal 0 either. Okay, so we're not going to cross the axis. All right, so number 1, it says find the exponential function f of x equals b to the x whose graph is given. Okay, so notice how I told you it's in this form, f of x equals b to the x. So we need to find out what b is. So you can plug in 0, 1, but 0, 1 actually works for anything. So see what would happen when you plug in 0, 1. I'd get 0 for x, and I get 1 out. Well, yeah, 1 is equal to b to the 0 power, right? B to the 0 is always 1. All right, so that didn't really give us anything. So let's try another point. Let's try 1, 3. So when I plug in 1 for the x value, I get 3 for the y value, for the f of x. So that's telling us b is equal to 1, right? Or b is equal to 3. Messing it up. So your function is f of x equals 3 to the x. Okay, now we have another point listed. We have 2, 9. So go ahead and check that in your head. If you plug 2 in for x, do you get 9 for y? Yeah, 3 squared is equal to 9. So that works. Okay, so that's your answer. Okay, let's do the same thing on this next one. Okay, so go ahead and plug it in. So I have f of x equals b to the x. I don't want to do 0, 1. That's not really giving me anything. So let's try negative 1, 4. So when I plug in negative 1 for x, I get 4 for y. Okay, so all that is 1 over b equals 4. Multiply your b over, you get 4b equals 1. So b is 1/4. Okay, I knew it was going to be a number between 0 and 1 because it's a decay, it's going down. Okay, so your function is f of x equals 1/4 to the x. Okay, you can check with negative 2 as well. Negative 2 would mean flip your base, so I'd have 4 to the positive 2, which is 16, so it works. All right, I want to do one more of those, so let me insert a blank page here. Okay, I gotta think about these ones. I realized your homework had some different ones. Okay, so let's say that we're in the form y equals p times a to the x. So that's like your M&M activity where you have a number out front, like if you started with 100 M&Ms, like we talked about. All right, so let's say when I plug in 0, I get 2 out. And if I plug in 1, I get 6 out. So find out what p and a are for those. So go ahead and try that. So you can put this in your additional notes or off to the side. Okay, so when I plug in 0, I get 2 out, so I'd have 2 equals p times a to the 0. 0 for x, 2 for y. What's a to the 0? 1, so that's telling me 2 is equal to p. So right away I know what p is. Okay, for this other one, when I plug in 1 for x, I get 6 for y. But I already know that p is equal to 2. So let's plug that in there. So I get 6 equals 2 times a to the first power, so 2a. So what's a? 3. Yep. So that means your function was y equals p was 2, a was 3 to the x. So that's your function. Okay. Now a lot of people want to write that as y equals 6 to the x. You actually cannot write it as 6 to the x. Because if I was plugging something in for x, I'd have to do my exponent first and then multiply. So you have to leave it like this. You can't say 6 to the x. Okay, so that's it. I'm getting kind of close.